Yeah, once again, good morning all. All of you, good morning.
Good morning, sir.
Yeah, yeah. In continuation of last class, we discussed about schedules. Here, I think everyone is understood schedules for transaction. In the last class, we discussed about schedules. All of you understood? Hello? All of you clear about last class schedules? Hello? Is this clear about last class? I told you I need a response. If you're not understood, then I will explain again. That is what I am asking. All of you understood the schedules, whichever we discussed in the last class? Hello?
Yes, sir.
Yeah. Please respond here quickly. Why you people are unnecessarily wasting the time as well as my patience you are checking. Okay. Now is this screen visible?
Yes, sir.
Yeah. Right. Now coming to last class, we discussed about schedule. We know when you wanted to prepare any transaction, we need to prepare a schedule. That schedule must be overlap. We can prepare a schedule for multiple transaction for concurrent execution. How to prepare and what are the rules we have to follow. Even same schedule, same problem we can prepare in different way of schedules. That all must be follow the rules so that you don't think compulsory every schedule must be same. Here, for example, I will tell you why the schedules are different. Have you observed bank ATMs? Everyone aware of bank ATMs, right? All of you aware of bank ATMs, right? Hello.
Yes, sir.
Now, when you are going to enter HDFC Bank, the procedure is different. Maybe it is going to ask first ATM PIN number. If you go Citibank, if it is going to ask end of after entering amount end when you are withdrawing before withdraw the amount, it is going to ask PIN number. Yes or no? All banks are not same procedure, right? ATMs, I am asking. All ATM machines are going to follow same instructions, same order of instructions, I am asking. Hello? This is common example, whichever I am discussing, everyone are aware. All ATM machines are going to follow same procedure to withdraw money. Hello? Morning, why you people are not responding? Hello? Is this my voice is audible?
Yes, sir.
Then if yes, my voice is audible, I am asking, everyone is aware of ATM machines or not?
Yes, sir.
Yes, sir.
Then if you are aware, all ATM machines are going to follow same order of instructions or different order of instructions.
Different, sir.
Yeah. But finally, from any, you can take any ATM card. Here, if you are having HDFC ATM card, but you are inserted into ICICI, it will be accepted. Everywhere it is accepting, but order of the instructions are going to change or not.
Change, sir.
Change. Means why it is changing, that is based on the bank requirement and based on their bank rules and regulations, they are going to readjust their schedules. Means one bank is follows First, whenever we are going to insert, it is going to ask enter PIN number. Yes or no? Especially HDFC. Yes or no?
Yes, sir.
Yes, sir.
If you go with some other banks, maybe other bank ATS, maybe Citibank or etc., it is going to ask that PIN number end of the transaction. Yes or no?
Yes, sir.
Yeah. Means both are going to have successful your transaction. In both the ATM machines, it will be done, your transaction is successful. Yes or no? Yes or no? So I'm trying to
Yes, sir.
explain real time. Yeah. Now, that is what the schedules, here whatever the schedules I am telling here some banks are using some of the order of instructions, some banks are using some other order of the instructions. Means if that instructions are must be same, but maybe the order is going to change. That's why some people will use schedule 1, some people will use schedule 2, some other they are going to use schedule 3. Means not only this schedule, depending on their requirement, they can use. Sometimes some schedules are not applicable. That is, as an engineer, you have to decide. That is what the different categories of schedules we discussed in the last class. Clear now? Understood? All of you understood? Hello? All of you understood the schedules. Why different schedules are there? Hello?
Yes, sir.
Right. Now, today we are going to, if you are understood schedules, then today's topic is very easy. You can understand very easily. Now, today we are going to discuss about the serializability. What is serializability? Tell me. Now, in a technical way, what is serializability? What is serializability? Hello. Hello. Serializability. Serializability is nothing but transactions are going to execute sequentially. Here, first T1 has to execute, then T2 is going to execute. Or T1 has to execute, then T1 is going to execute. Like that, there is no chance to execute both the transactions at the same time. That is a concurrency. We are going to execute. But serializability means if there is no chance of execution of multiple transactions at the same time. That is called serializability. Clear? Clear? Hello? Hello?
Yes,
Hello?
sir.
Is this my voice? Why you people
Yes,
are
sir.
not
It's
responding?
good.
Yeah. Please respond, Yogita, at least one of you, any one of you, please. Then only I can understand. My voice is audible or not. Right. Now, what is the importance of the serializability? As I told you yesterday, generally any mechanism will execute only serializability, but actually we need concurrency mechanism. Based on the serializability, we are going to implement the concurrency mechanism, so that we need to understand how serializability will work. Based on serializability things, we have to achieve the concurrency. How we are going to move into the concurrency, we are going to understand. So that we need to understand first serializability. How many serializability techniques are there? How it will be work? Understand? Now understood why I am discussing serializability now? Because I want to achieve concurrency in a transactions. Because if the concurrency is there in the transaction, we can achieve more durability, more speed, more fast, multitasking, multi-transaction I want to perform. Nowadays, we are using the type of scenario for every bear or every bank or every financial sector. So that we need to understand. For that, first of all, we need to understand serializability. Serializability is a common mechanism. Understand? Hello?
Yes, sir.
Now, as I told you, serializability generally it will preserves the consistency. Why it is preserving the consistency? As per the things, first execute T1, then go to T2. Then automatically here the consistency will be there because here one transaction is not depending on other transaction. It is finished so that I am starting. So that I can get the isolation, automatically I can get the consistency. That is the advantage of serializability. Understood? Understood?
Yes, sir.
Yeah, this is a theoretical unit completely. There is no practical things, but practically I am telling, real-time exams I am telling, please understand and more lengthy unit, please don't waste the time. Thus, the serial execution of set of transactions preserve the database consistency. Already told you. Now we have two categories of serializability. Please remember, very important is conflict serializability and view serializability. Okay, in this transaction management, the serializability will be achieved based on two things. One is conflict serializability, another one is the view serializability. We will learn very clearly what is conflict serializability, what is view serializability. Don't worry, now we will discuss. Okay? Hello? All of you clear?
Yes, sir.
Yeah. Now, when we are going to perform a transaction in the view of transaction, we need to consider only read and write operations. We don't want to consider remaining operation because in a transaction we have only read and write operation. So that we need to consider only read and write operation. Clear? Clear? Hello? Is this clear? Is this clear? Sir, instead of telling
Yes,
topic,
sir.
I am asking more time, clear, clear, clear. What is the use? Time waste. Right. Now we have two categories of serializability, conflict serializability, view serializability. And now we are going to discuss about the first conflict serializability. Before going to enter into the conflict serializability, we need to understand what is conflicting instructions. Very simple, very simple. Here I am writing here transaction. Here, all of you, when I am writing T or when I am writing automatically, everyone is reading or not? Here, out of in this class, 50 students are there. All 50 students are. This data is reading or not when I am writing? Hello?
Yes, sir.
Please answer my
Sir.
question. When I am writing, everyone is reading concurrently, right? When I have started here, for example, if I am starting like this D, that whatever the shape I am writing, now you are reading directly. Yes or no? Without any conflict, without any problem. Yes or no?
Yes, sir.
Everyone is reading only DBMS or any other data they are reading. So all of you are reading same data or not? Whenever I am writing. Hello? Hello? Hello?
Yes.
Now, when I am reading multiple, when I am writing, here other process are reading. Means there is no any conflict. Yes or no? Here all are reading. Is there any conflict?
No,
No,
sir.
sir.
Yeah, sorry for the inconvenience. Just power was disconnected. Have you understood now? Hello. Now, when I am right, when the data is there, here all 60 students are reading same data or not? Hello. Is this my voice is audible?
Yes, sir.
Yeah. When this data is there, conflict instructions, here all 60 students are reading. The data is any problem? All are reading same time. Is there any problem? All are reading same time. Is there any problem?
No, sir.
No
No,
problem.
sir.
When means when multiple read operations will be performed same time, there is no chance of conflicting of data. Yes or no? Accepted?
Yes, sir.
On board, I've written some data, then I told all of you, please read. Then everyone will be read. There is no any conflict. Everyone will get same information. So that there is no data loss, there is no any conflict of the data. Yes or no? Yes or no?
Yes, sir.
Yeah. Now I told to you, here all of you please come and write on the board. Everyone I will tell you, write on the board. Then conflict is there or not?
Yes, sir.
Your own data. Conflict are there or not? The data cannot be understandable. Yes or no?
Yes, sir.
Now I tell write one guy and read other guys. Sir, when they are writing, maybe if I want to write DBMS in my mind, but I started D, then already some of the people are going to read D only. But my intention is DBMS. But when I am writing, someone other is reading, automatically data is going to conflict or not? Sure, I'm thinking I want to write DBMS, but just I have started with D. Automatically, the people who are reading, everyone is reading D only. So that the data, I am thinking this is DBMS, but others who are reading, they will think only D. Now, data is going to conflict or not?
Yes, sir.
Yeah, means except all are reading, remaining all the cases, the data is going to conflict at a time if you want to perform more than one operation, read or write. Yes or no? Yes
Yes,
or
sir.
no? Yeah, for that, now this example
Yes,
is
sir.
that only generalized way I told you. Now instructions LI and LJ of transaction TI, TJ, two transactions we have TI and TJ. Now LI is one instruction of TI transaction, LJ is the one instruction of TJ transaction. Here the conflict is sometimes is going to happen when we are going to access Q object. How it will be happen? We'll check. Here LI means instruction of transaction TI, read Q and read Q. Here TI transaction, this is TI transaction, this is TJ transaction. Here both are read. Okay, reading of Q, same object we are doing. So please remember, the same object. Here read and read perform means both people are doing read only. Here one person is reading, maybe the Anusha is reading, and other guy, maybe any name, Vamsi is reading. Now both are reading. Is there any conflict? Already data is there, they want to read. Both are reading. Is there any conflict? Hello? Both are reading. Is there any conflict?
No, sir.
No, sir.
No conflict. Here now, one guy is reading, another guy is writing. Here now I am reading, now other guy is writing. When they have written D, automatically I will read D only, but they are uttering their data. So that is what the conflict will be occur. Yes or no? Yes or no?
Yes, sir.
Now other one guy is writing, then other guy is reading. Again conflict will be occur. Yes or no? Yes or no? Yeah. Now one guy is writing, other guy is writing. Both are writing. Again, the conflict will be occur because we cannot get exact data. Yeah, except multiple reads, remaining all combination of operations are going to get conflict. Except multiple reads, we can have multiple people they can read here because if you go to the cinema theater, here movie is going on, everyone is just watching and reading maybe the instructions, then there is no any conflict, there is no any disturbance. Here in auditorium or somewhere, someone is telling something, everyone is listening, that is not a problem reading. But when all are talking, then we cannot get exact data, that is conflict. Understand? All of you understand? All of you understand this conflicting instructions? Clear this?
Yes, sir.
Means if we want to achieve a concurrency mechanism, yes, we can apply multiple reads. The same object we can read in T1, T2, T3, T4, n number of transactions, we can read Q object at a time. There is no problem because there is no chance of conflict. But when one transaction is reading, other transaction is trying to write, there is a chance of conflict. So that such type of conflicting instructions you never use in your schedules. So that is what conflicting instructions. Clear? All of you clear? Please, guys, respond quickly. All of you clear?
Yes, sir. Clear.
Yeah. Now, coming to the first one, conflict serializability. Yeah, very simple. As I told you, if a schedule S can be transformed into schedule S dash. So, what is the meaning for this? Here already I told you schedules. Yeah, for example, if you feel this is a S1, the same schedule we are rearranged with swap of some instructions for this S1 dash. Yes or no? Same instruction we swapped and we implemented, right? Hello.
Yes, sir.
Both are same, right? This S1 and
Yes,
S1
sir.
dash both are same, right? Yeah. Now that only I am going to take, then I will tell you. If a schedule S can be transformed into schedule S dash by a series of swaps of non-conflicting instruction. Non-conflicting, you know, conflicting means these three are conflicting. This is the non-conflicting, means both contains read, not a problem. We say that S and S dash are conflict equivalent serializability. These S and S dash are conflict equivalent. Understand? This S and S dash are conflict equivalent. Understood? All of you understood? Hello? Hello?
Yes, sir.
Yeah, same. The schedule is conflict, S is a conflict zero. So that the S is a conflict zero. Means if we are going to write the S into S dash with the help of some non-conflict instructions, then these two are is a conflict equivalent. Then S is called as a conflict serializable schedule. Clear this? Clear this? Don't expect all the
Yes, sir.
schedules we can be transferred from S to S dash. It is not possible for all schedules. Only it is possible for some schedules. So those schedules are called as conflict equivalent. That schedule is called as conflict serializable schedule. Clear? Very important, please, guys. All of you clear this? That is what yesterday I told you the schedules very clearly. Clear?
Yes, sir.
Yes, sir.
Now I will tell you again one more example also, same example, the schedule. If you take the schedule 3, read A, write A, read A, write A, read B, write B, read B, write B, T1, T2. Now this is if you take S, now I am going to convert this schedule into another schedule. I am checking, yes, it is possible or not. Yes, it is possible. Here I want to take all together into T1 and all together into T2. Now it is possible. Yes or no? Possible or not? Both are same or not? Schedule 3 and Schedule
Same.
6 are both same. If it is same means these two schedules are called as conflict equivalent. Yes or no?
Yes,
These
sir.
two schedules are conflict equivalent, and schedule 3 is called as conflict serializable schedule because this is providing another set of schedules, so that this schedule 3 is called as conflict serializable schedule. Clear? All of you clear?
Yes, sir.
Yeah. Now I will tell you another schedule which is not conflict serializable, because can anyone tell this is a schedule if you take S? Is there any chance to prepare another schedule for this S? Any one of you please? Is there any chance to prepare another schedule for this using this schedule which wrap up some instructions in this schedule? Hello? Is there any chance to write another schedule for this schedule which wrap up some of the instructions in the given schedule?
No, sir.
No. If it is no means, this is not a conflict serializable schedule. Here I will give a clear examples, please. Here how, why it is a conflict serializable, why it is not a conflict serializable. Very clear. If there is any chance to produce another schedule for the given schedule, so that schedule is called as conflict serializable schedule with following of some sort of instructions. When we are not providing, when we are not designing a schedule for the given schedule, that schedule is called as not a conflict, non-conflict serializable schedule. Clear? All of you clear how to define the given schedule is a conflict serializable or not? Hello? Please ask me. Still, if you are having doubt, please ask me. Very important. Everyone is understood? Conflict serializable, not conflict serializable? Hello, I'm not getting any response from your side.
Yes, sir.
Clear? Conflict serializability is clear now?
Yes, sir. Yes, sir.
Yeah. Now next serializability is view serializability. What is a view serializability? Here in a view serializability also, we have three rules. We need to follow three rules for checking of the view serializability. Let S is a schedule and S dash is another schedule to be two schedules which is the same set of instruction. Exactly what I told you. Here, if you take this is S, this is S dash. Yeah, both are having same instructions. Please remember these three rules. Please note it down. Otherwise, if you are confusing, yeah, this is S and this is S dash. Okay, we are prepared a S dash schedule from the S schedule. Okay, happy, 100%. Here, then in that S and S dash are view equivalent with the following three conditions are met. The following these three conditions are going to reach when we are going to prepare S to S dash. That S schedule is called as view equivalent or view serializability. The first condition is if in schedule S, for example, if you take this is a schedule S, this is a S, okay? If you take the schedule S, transaction Ti reads the initial value of Q. The transaction Ti. The Ti means T1 here, T2. Y, J, 1, 2 I am taking in S. Here, object is A. Here, now what I am doing in a transaction Ti, you must be read A. Means yes, I am reading A. For example, if I read A in a transaction Ti, initial value of Q. Then in schedule S dash also transaction Ti must be read the initial value of Q. In a schedule S dash also, yes, this is S dash. Now in a transaction Ti, yes, Ti. Now the S dash first initial value must be read A. Yes, here also read A, here also read A. The first condition is true. Understand? All of you understood first condition? Hello?
Yes, sir.
Yeah, means if in a first schedule, first transaction, if it is reading a object as an initial value, in second schedule, first transaction, it must be also read the initial value of same object. That must be this. If it is Q, here also Q. If it is A, here must be a. If it is K, here must be a K. This is the first rule, first and foremost important rule for view serializability. Clear? With example, clear? A. Yeah. Now coming to second rule. If in schedule S, transaction Ti executes read Q and that value was produced by transaction Tj, if any, then in schedule S dash also transaction Ti must read the value of Q that was produced by the same write Q operation of transaction Tj. Means here have written T1 read A in transaction T2 again means read A. Here I am using write A. Yes, it is done. In the same way, if we are using read A, here it is produced at write A. Understand? Again, I am reading if you are confusing. If in a schedule S, first schedule, transaction Ti means T1 executes read A. We are reading a Q object and that value was produced by transaction Tj, if any. Any, if it is going to done, if it is done, this is always not compulsory. If it is done in the S transaction, same must be done in the S dash transaction. Also, transaction Ti must read the value of Q that was produced by the same write Q operation of transaction Tj. Clear? Clear? All of you clear? Second rule. Hello? All of you clear about second rule? Hello? I'm not getting any response. Is
Yes,
this
sir.
clear? Yeah. Please respond quickly. Time is running. Now coming to the third rule. The transaction that performs the final write of Q operation in schedule S also perform the final write operation in the schedule S dash. Means if in the schedule the final write maybe here write B is there in a transaction T2 of S, compulsory in S dash also T2 the final write must be B. Yes, it is there. If it is not there, it is also not required write operation. If it is there as a final operation in a schedule, one transaction, any transaction is write operation here. Here write B, yes, here write B. Here, if it is final operation, must be a write operation of object. That same object must be write as a write operation in a S dash schedule. Understand third rule? All of you understood third rule? All of you understood third rule? Hello? Hello?
Yes, sir.
What is good? Please respond quickly. Clear? Third rule is clear.
Yes, sir.
Yeah. Now, if any schedules S and S dash are following these three rules, those S and S dash schedules are called as view equivalent, and that S schedule is called as view serializable. Clear this? Clear this? Understood the view serializability? All of you understood this view serializability? Hello?
Yes, sir.
Yeah. Now, if a schedule S is view serializable, if it is view equivalent to serial schedule, exactly. If it is a view serializable, 100%, it is a serial schedule, 100%, because already just now we verified. If it is a view serializable, compulsory it is a serial schedule. Understand? Understood? Hello? It is a default condition. If it is a view serializable, if you are observed, the given schedules are view serializable. Compulsory, it is a serializable schedule. Clear? Clear? Hello?
Yes, sir.
Now, this is a schedule they are given, another set of schedule. This schedule, the following schedule, which is a view serializable, but not conflict serializable. Yeah, means maybe there is a chance all view serializables are not a conflict serializable, because, for example, if you check view serializable rules here, your T3 is reading Q. If you perform another schedule, if you want to do another schedule, we cannot have another schedule. Is there any chance to write another schedule? This is if you S, is there any chance to write S dash schedule for this? Is there any chance? Tell me. This T3, T4, T6 S schedule, is there any chance to convert to S dash? Is there any chance? This schedule is possible to convert S dash. Hello? If you feel this is
No,
a
sir.
S, and no, it is not possible, because here write Q, now read Q, write Q. Now S dash how to write? It is not possible to write. For example, if you take T3 read and write Q, then for T4, where should we write? We cannot write. We have to read. So that it is not possible to implement S dash. So that if you observe the given schedule as it is view serializable. How? Means as per the discussion, the first rule is your first T3 instruction must be read. Yes, read is there. Here T4 is writing based on the T3 read. Yes, it is doing. And last statement must be right. Yes, it is right. Then it will be a view serializable. But this is not a conflict serializable, because we cannot convert S to S dash. So that this given schedule is not a conflict serializable. Clear? Clear?
Yes, sir.
Yeah. Now
Yes, sir.
such type of schedules are called as blind writes. Means the schedules which are view serializable but not a conflict serializable. Such schedules are called as blind schedules. Please remember, interviews people will ask what is blind schedules. Means the schedule which are in a view serializable mode but not a conflict serializable mode. Such schedules are called as blind writes. Those schedules serializable as blind writes. Clear? Remember this word, I have noted down. Very important point it is actually. All of you clear? All of you clear?
Yes, sir.
Yeah. Some other notations, if you want to use here, the conflict equivalent or equivalent to it. These schedules, if you are going to observe, here this is a we can convert. If you take this is S and you can convert S dash or not. From S to S dash, can you convert or not this? Hello?
Yes, sir.
Is this possible or not?
Possible.
If it is possible means, then what is this S and S dash are? conflict serializable schedules? Yes or no? S and S dash is
Yes.
serializable schedules. Yes or no? S and S dash is serializable schedule or not?
Yes,
Yes,
sir.
sir.
And S is a conflict serializable schedule. Now we'll check view serializable. S is a view serializable or not. Now it is following three rules are not checked. Here read A, again here read A, read B. Here read A is there. Here read A and read A. Yes, it is first rule is satisfied. And here if you are reading here A and write A here. If you are reading B here and write B here. Here finally third condition, write B, write B, write A, write A. Here finally write A, write B. So that it is satisfying three conditions of view serializable. So that this schedule also a view serializable, conflict serializable as well as view serializable. Are you clear? Are you clear?
Yes, sir.
Yes, sir.
Now the next topic is recoverables. Yeah, the next topic is now serializability is over. We have two types of serializable schedules. One is view conflict serializability, another one is the view serializability. Here we must understand those serializable schedules and it is very important. Now coming to the next topic, recoverable schedule. Sir, what is this recoverable schedule? Means any failure is going to happen, any problem is going to happen in a transaction, then these schedules how to recover, because if we are not going to recover, the data is going to loss. Here, if the data is losing, means data is inconsistency. Here, users are going to loss. Maybe if it is a financial application, the people are going to lose the financial things. So that we need to recover. We need to recover those schedules. So that so that we have the implementation of schedule in the form of recoverable schedules. Just now we discussed about schedule and serial schedules, how the serial schedules will be done, categories of schedules, that is a conflict serializable schedules and view serializable schedule. In the same pattern, here we are extending. Here in this unit, every time we are learning some features we are adding every time. Please remember this point. If you are going to miss the previous class, today's class you will never understand. If you miss today's class, next class you will never going to understand, because it is a adding the things. Now recoverable schedules. Here only we verified serial, non-serial, or view or non-view. But now along with that we need to add one more flavor, that is a recoverable. Means the schedule is as it is, whatever we discussed. Then we have to add a recoverable. Means any failure is going to occur. Then how to recover the data? Because our intention is we need to provide the end user atomicity, consistency, isolation, durability. So these are the four properties. So if any loss is going to happen, compulsory someone is going to lose, data inconsistency will be happen. So that at the time of implementation of schedules, we need to add recoverable, so that any data is going to loss at the time of transaction, we can be recovered. So that now we are going to discuss about the recoverable schedule. Clear? Why recoverable schedules? All of you clear now?
Yes, sir.
Yeah. Now, already I told you the transaction failure on concurrently running transaction. We need to address this effect of recoverable schedule. The recoverable schedule, if a transaction TJ reads a data item previously written by transaction TI, then the commit operation of TI appears before the commit operation of TJ. Means the meaning is, if a transaction TJ, this is a transaction TJ reading, the read A, then which data it is reading? After writing of A in a transaction T8, now T9 transaction is reading save object data. Here, when we are reading, then the commit operation of Ti appears before the commit operation of Tj. The commit operation of, what is the meaning of commit? Already I told you before this. Tell me what is the meaning of commit?
Successfully executing the actions.
Yeah, here that is the meaning generally. Now I will give the complete information. Now, here whatever the transactions are executing here, it will be execute only in a primary memory. Here all operations are executing. When you are going to get commit, means when you are going to enter ATM, you are inserting your card, you are entering all the details, enter amount, enter pin, all these things. Here, once your transaction is successful, now this is will be done only ATM area. Once your transaction is done, this total data is updated to server, bank server. That is called commit. Means the data is going to stored into the secondary storage at the time of commit. Here, that is the meaning. Here, whatever the operations are going to done, it is in a primary memory only. Means that ATM machine only. The same way, here when why commit is required means your whatever the task you are done just now, all are right. That will be updated to the server. Now understood why the commit is required now as a technical. Now we are entering technically. Have you understood as a technical student what is the meaning of commit? Have you understood now?
Yes, sir.
Now come to the point. Yeah. Then the commit operation of Ti appear before the commit operation of Tj. Exactly. Because, for example, here T8 read A, write A, but here I have not written any commit operation. Now I am reading. Here, if I am not committed here, what is the meaning? It is not updated into the database. Yes or no? If I am not committed here, this data, whatever the write operation is performed here, this is not updated in the database because I have not taken commit here. If I write commit here, the data is stored, whatever the write data is done, it will be stored into this database. Now T9 is going to read A, the data will be come from here, the exact updated data by T8. But here I have not written any commit statement here. Then what happened? Sure, I can get this updated data or not, I don't know. Understood? Hello? All of you understood my intention? Hello? Hello? All of you clear?
Sir, can you repeat once again?
Yeah, sure, 100%. Sure, already I told you, whatever the operations are going to perform ATM machine that are going to done at the ATM machine only. If transaction is done successfully, because can you check, can you tell when you are inserting ATM card into your machine, automatically you will get the message to your mobile. Your transaction is started like that, it will be get.
No.
No. Here, when your transaction is done, means completed successfully. Means commit. Commit means here when all these operations are done, so that is going to stored into the your bank account, bank data. Now the trigger will be fired when the commit will be done to here. The trigger will be triggered. Then that is going to send to your message will come to your mobile. Means the commit is nothing but storing the data permanently into the secondary storage. So that is the meaning of commit actually. Understand? Understand? That is
Yes.
why the commit we are going to write
Yes, sir.
the transaction when successful. Now here T8 T9 transaction is there. T8 is read A, write A, and T9 read A. Now here I have not written any commit statement here. Read A I am doing. Now the data is coming from this only. But this write A data is updated in the secondary storage or not? Read A, write A. Sure. T8 is writing some data on A object. That updated data is there in the secondary storage or in a primary only. Hello? Sure. You are asking to repeat, I am repeating, you are not answering.
It's not stored.
Not stored. If it is not storing means this read A, T9 operation is performing reading of A. Here that A may be updated data will get or previous data will get, we don't know. Yes or no?
Yes, sir.
Yeah. So that's why there is a chance of problem. There is no chance of recoverability. But if you write commit statement here in a TI, after write, if you write commit statement, the data is stored into where? Secondary storage. Yes or no? Yes or no?
Yes, sir.
Here, once commit, if is there any problem, any error or anything is there, then we can recover very easily, because when I am going to read, then data will come from the secondary storage, because the data is updated already in the secondary storage. If you won't write, now I wanted to read, now any problem will be occur here. Now the data cannot be recovered to T9 because it is not stored anywhere in the secondary storage. So that's why when you are going to write a commit statement before TJ, that must be right before TI. That is the meaning of this. Yeah, then the commit operation of TI appears before the commit operation of TJ. Means you need to write commit here before this. Then only this data will be stored. Once the operations are done, this will be stored here. Now the data we can use here. Now again the data will be stored here. Like that, every time before whatever the transaction is going to be done, that transaction must be committed, means that must be stored or updated in the secondary storage, so that we can be recover the data. The schedules are going to recoverable. So that is the meaning of the recoverable schedule. Understood?
Yes, sir.
Now clear what is the commit, why you are using, how we can perform recoverable schedules. All of you clear?
Yes, sir.
Yeah. As per my knowledge, everyone is understood serial schedules as well as recoverable schedules. Clear?
Yes, sir.
Yes, sir.
Yeah, already I posted third unit notes in a Google class. This fourth unit PPT also I'm going to send in a Google classroom. Please go and verify and follow up. Please practice. If any doubts are there, you must be asked. This is a looking like a theoretical unit, but it is a real-time examples are going to involve more. Those real-time examples are not going to have in your notes and textbooks. Here, whatever the things are there, I am explaining in my class. Please try to note it down on your notebooks. That will be help you a lot at the time of preparation and your interviews and your placements. Even when you are going to join any company, if you are working related to the database side, 100% I am telling, my experience is going to help a lot for you. So that you need to update the things on your notebooks. Is it clear, everyone?
Yes, sir.
Sir, why I am telling this? Sir, I am very confident because lot of your seniors are working in the